A rectangle is a parallelogram with 4 right angles. And has the following properties. Opposite sides are parallel and congruent. Parallel and congruent. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. So all the same properties as a parallelogram. The only difference is that all 4 corners are 90 degrees. Okay? All 4 corners are 90 degrees. All right, I'm gonna do a couple of examples, and then I'm gonna turn you loose because you did parallelograms for a whole week last time around. So draw a rectangle on your paper and draw the 2 diagonals. And then starting in the upper left hand, at the upper left hand vertex, label that A, and going clockwise, go alphabetical. And where the diagonals meet, we'll call that E. All right, and let's say that A to B is 6 feet, and A to D is 2 feet. The measure of DAE is 65. DAE is 65. You define BC, DB, CEB, angle CEB, and angle EDC. All right, so let's take care of the obvious first. All right, if the left side is 2 and this thing is a rectangle, then what's the right side? Good. If the top is 6, what's the bottom? 6, good. All right, so this vertex A, what's angle DAB equal to, this whole upper left corner? The whole upper left corner is 90, right? So if you take 90 and you subtract 65, what's left? 90 minus 65. 25? Okay. Now if the left side is parallel to the right side and the top is parallel to the bottom, then aren't the diagonals transversals? Diagonals are transversals. So if this angle EAB is 25, what is angle ECD? ECD is 25 as well. Good. Bless you. If that angle is 25, what's angle ECB? 65. Good. See where we're going with this? Now, these angles where the diagonals intersect each other, they're vertical angles, aren't they? And they're congruent. So you got that one's congruent to this, and this one is congruent to this one. And if you look around, this top triangle right here, triangle ABE, is going to be congruent to triangle CDE, isn't it? By angle-angle side theorem. Okay? So, if this is 25, what is this over here? That's 25 as well. Which makes this angle in here, EBC is 65. So over here around vertex D, you got angle ADE, and it would be 65. And angle EDC would be 25. And then around to where the diagonals intersect. Let's go back to triangle ABE again. If these two angles are 25 each, what's this third angle in here? 25 and 25 is 50? 130, isn't it? All right, and if that's 130, what's the angle below it? 130. Now, these two make a linear pair, don't they? You got a linear pair right here. So angle BEC would be 50. And it's vertical to angle AED, and it would be 50. So now it doesn't matter what question they ask, you've got all the information. We're only missing one thing. Let's see. B to C, we did that. That was 2. D to B, this piece right here. D to B, that's a diagonal, isn't it? All right? And you're dealing with the right triangle here. So how could you find the distance from D to B? Pythagorean Theorem, very good. That's the hypotenuse of a right triangle. So you can do 2 squared plus 6 squared equals c squared. So 4 plus 36 equals c squared. 40 equals c squared. And radical 40 is going to be equal to c. Radical 40. 6.32. D to B, 6.32. Angle CEB. C, E, here in the middle to B, that is 50. And angle EDC. EDC is 25. Very good. All right. Any questions there? Pretty straightforward, huh? Good, good, good. Look at page 425. Example 4. Coordinate geometry example. Quadrilateral PQRS has vertices. Determine whether PQRS is a rectangle by using the distance formula. The distance formula. So let's plot that real quick. All right, since you're using coordinate geometry, and if you put your y-axis in and your x-axis, and plot that shape. You got point P. is at negative 5, 3. So we'll go negative 5 and 3. That's negative 5, 3. Q, 1, negative 1. So 1, negative 1, right here. Negative 1, negative 4. So negative 1 and negative 4. And finally, negative 7, 0. Negative 7, 0. Now, they're asking you to determine whether PQRS is a rectangle using the distance formula. What have we used all year in here instead of the distance formula? Pythagorean theorem, right?
Yeah.
Pythagorean theorem. So watch what you can do. Instead of doing the distance formula, let's see if this left side over here is congruent to the right side. All right? So, using the Pythagorean theorem. So turn this into a right triangle right here. And watch, you don't have to use the whole Pythagorean theorem. Okay? Turn this into a right triangle. So if you go vertical and horizontal. What's your vertical change right here? Going from 0 to what? Going from 0 to 3. So what's your vertical change? 3. What's your horizontal change? 2. So 3 squared plus 2 squared equals c squared, right? Don't do the math, though. Just do the same thing on the right. Go down here, drop this down, and drop it horizontal. What's your vertical change? 3. And what's your horizontal change? You're going from negative 1 to 1, so what's that change? 2. So you got a right triangle with legs of 3 and 2, and a right triangle with legs of 3 and 2. Are those hypotenuse congruent? Yes. So that piece is the same as that piece. Now, do the same thing on the top and the bottom. All right? Turn this into a right triangle here. Here's your horizontal, and here's your vertical. Okay? What's your horizontal change? You're going from negative 5 to 1, aren't you? So that's a 6 change. What's your vertical change? Going from 3 to negative 1, so 4. Good. So now, make another triangle down here. Another right triangle. And what is your vertical change?
4.
4, good. And what's your horizontal change? You're going from negative 7 to negative 1, 6. So are those two hypotenuse congruent? Yes, they are. So is this thing a rectangle? Yes, it is. By using the distance formula. That's a version of the distance formula, isn't it? You don't need to find those 4 distances by grinding out a bunch of numbers. Just turn them into right triangles and see if the legs are congruent. Yes. Yes, Greg. Any other questions? Does everybody understand that concept? You don't need to use the distance formula, okay? And you didn't even need to do the Pythagorean theorem. If you just construct some right triangles and the legs are congruent, the hypotenuse will be congruent. All right? All right, turn to page 426. On page 426. Problems 14 through 19. And then moving over to the next page, do 22 and 23. And then 26 to 31. And let's see. Answer the focus question. And check headline for homework.